All right. So we don't really have new material today. I'm gonna repeat the last thing we've discussed the last time, which is the palindrome exercise. I know we rushed through it because of time on Monday. And then I'll discuss one exercise maybe from the assignment, and then we can open the discussion and reflection. That's all right, Rawat. Okay. So we're talking about the exercise, which is the palindrome, and we had a brute force algorithm that we've discussed. I'm not going to discuss again. So the brute force algorithm works by generating all possible substrings. So we take a string, like let's say I have the string X and then ABBA, and then W, let's say. So this is my string. What it does is it generates all possible substrings of the string. So it loops over all, over the string and tries to generate all possible substrings. So all possible substrings would be, X, XA, XAB, and so on. So we have X, right? We have X, A, X, A, B, etc. Yeah, and then you have A alone, and then you have AB, then you have ABB, and so on. You keep trying to do this. That's called the brute force algorithm because you're generating all possible substrings. Then you check each one of these substrings. Is it a palindrome, yes or no? If it's a palindrome, you keep track of its length, and then at the end, return the longest palindrome, okay? And we said this algorithm its complexity is cubic, so n cube, where n is the length of the string. Why? Because I have here two nested loops, yeah, each run a maximum of lengths of s, or a maximum of n. And so that's n squared. And then the palindrome function, this function, don't forget these functions that you call inside. They also are expensive. They involve operations, so take time. So palindrome of a string takes order of the length of the string. And since we're generating all possible substrings of a string S, this could be a length of, a maximum of a length of the string itself. Yeah. So in total, I'd have, in the worst case, this algorithm is big O of n cubed. Okay. Now there is this other smarter algorithm, which is faster, and we'll see why it's faster, that tries to find the longest palindrome through a small observation. Yeah, so the strategy as follows. You have a string, let's say X, the same string from the previous example, A, B, B, and then W. Okay, so what does it do? It tries to go for every character inside the string. It tries to expand around it to see if there are any palindromes. Yeah, so for X, it's a single letter. There's nothing. I cannot go before it because it's the first letter, so there's no expansion here. But for A, I might want to see, okay, A itself is a palindrome because it's a single character like X, but maybe if I expand on the left and the right, I'll get a larger palindrome. So if I do, look at the character before A and the character after A. If they're the same, then I found the palindrome, and I can expand even further to see if there is a longer palindrome around A. Yeah. So here, since X is not the same as B, I stop, and the longest palindrome around A is just A itself for the length of 1. I can go to B and do the same thing, right? So for B, I can expand around it. So I have A and B. Okay. So for B itself, it's basically just there is no palindrome around. Yeah, and so on. So this is the strategy, but there is a distinction here, right, between even and odd palindromes. Yeah. So here, right, let me just erase this and change the example a little bit. So let's make it X, A, B, B, A, and then let's say V. Okay, so the longest palindrome is really the word ABBA. And if I do just look at, for every character, look at the previous and the next, I will never be able to catch this ABBA. So I need to also take into consideration for even palindromes that I want to look at, you know, the character. Yeah, so I'm at B. Yeah, look at also this guy. So the character and its next, right? That's for the case of even. And if I have something odd like this, A, B, C, B, A, V, right? So the longest palindrome here is A, B, C, B, A, and it's an odd palindrome. For C, I would look at the previous, yeah, and the next. So for the even, I look at the character and its next. For the odd, I look at the previous and the next. Okay, and I can do this over every character in the string to find, you know, any palindrome and keep track of the longest length. So I have two functions. One that takes, you know, the string, where should I start and end, yeah, and then there is the one that loops over every character inside the string. Okay, so let's look at this guy first. Let me see if I can scroll. Again, okay, so let's scroll down. So I'm looping here over every character inside the string, right? Over X, A, B, B, and so on. And then I have two cases. One where I have the odd case, and one is for the even case. Okay, so for the odd, I'm going to send, you know, the start and the end as the same index. Yeah. For the even, I'm going to send the start as I and the even as I plus 1. Let's see what this means by looking at this function expand and count. So here's expand and count. This is what it does. It takes a string, like, you know, let's say the string X, A, B, B, A, okay, so, and then V, okay, so that case is the even, okay, so when I'm doing even, I sending I and I plus 1, right? So start is, sorry, yes, is I, and the end is I plus 1, okay? So I'll get here, you know, for B, the start is 2 and the end is 3. So I'm going to check, right? Is, you know, S of 2 is the same as S of 3, yes. So, you know, reduce the start by 1, so I get to A, and increase the end by 1, so I get to the A. So now I'll check, is A equal to A? Yes. So now I have a palindrome of length 4, okay? Now, the next time I change the start and end, I'll get to the X and V, and they're not the same. So I will stop, I'll exit this loop, and I'll return ABBA. Okay, so I'll return ABBA, and once I return ABBA, I get its length, right? And check if it's greater than or equal to the maximum length I've seen so far. Okay, so now what if I have sent, you know, if I have a palindrome that is odd? Okay, so I have something like X, A, B, C, B, A, and then B. Okay, then I'm going to send the start and the end as you know, the same value. So let's say I'm at C, and I want to see if a palindrome exists around it. So I'm going to send, you know, the start and end to be both the value 3. So yes, S of start is equal to S of end because of them are the same value, and so it's the same character C. So now decrement the start by 1 and increment the end by 1. Now I'll check B equal to B, yes, so I can continue in the loop. A is equal to A, yes, I continue in the loop. And then the next time I will have X and V, they're not the same, so I'll exit the loop, returning this string, which has, you know, a length of 5. Now I go back to the caller here, Okay, so now I've done for every character, figure out what are the palindromes of even palindromes and odd palindromes around it, then check which one is longer. So I check the length of the even. Is it greater than the length of the odd? If yes, then the longer one is the even, otherwise it's the odd. And finally, keep track of the longest. And at the end of the method, just return the longest palindrome. Okay. Roughly, I mean, it's a slightly complicated algorithm, but this is really the intuition behind it. Questions? Let's try it out. Yeah, so I'm going to clear, and then I'm going to go here and run just to see if it works on Python. Palindrome 2 py, and as you see, it returns the x, y, y, x. Okay. Now, what is the complexity of this algorithm? Can anybody tell me? Look at it. We're claiming that this is more efficient than the brute force algorithm, which was cubic or n cubed. Okay. So anybody can tell me what is the complexity of this algorithm? So the main function is the longest palindrome, but there is also this expand and count function that has its own complexity. But for the longest palindrome, from what you see here, right, what is its complexity? Any thoughts? You don't know? Nobody knows? How many loops do I have here?
Just can you go up a bit, please?
Sure.
Just to see for the complexity.
Yeah.
Only one.
Only one, right? So as Muhammad.
So it's
right.
an S.
Length of S. Okay, great. That's the complexity of this function, right? Or of this loop. But then I have this function, expand and count. Yeah, I have to also consider maybe it, it has a loop inside of it and it has its own complexity, correct? So I have to look at its complexity, yeah, because it's nested inside this outer loop. So what is the complexity of expand and count? It takes a string, a start position and end position, and loops over the string. So it goes from, the character, goes to the right and to the left. So what is the maximum, number of times or the maximum complexity of this function? Starts, it could be starting from the middle, could be starting from the beginning, it doesn't matter, but what is the worst case? How many, would it have to go over the whole string? Again, length of S, right? That's the maximum time. So I have, a loop that is length of S, and inside of it, there is a function that I repeat that is order of length of S. So what is the whole complexity of the program? Or the whole complexity of the longest palindrome? It's length of S squared, exactly. Yeah, so it's length of S squared. Here is one length of S, and here is another one. Each one is, length of S, but I'm not doing them nested. I'm doing them consecutively, so it's, constant. Yeah, so it's really length of S squared. Okay, compared to the complexity of the brute force algorithm, which we discussed, and it's n cubed or length of S to the power of 3. Okay. Questions? I hope now we can, go back and try to implement this function without any difficulties, and be able to see why it's definitely more efficient than the brute force algorithm. Okay. Now, I had in mind to do the sorting of the fractions with you, so we'll do that just because I think it's a cool exercise. And then I will just say goodbye and discuss any things you want to discuss. So in one of the exercises in the assignment, we wanted to use the merge sort algorithm, which we discussed on Monday, to sort a list of fractions. So here's my code. It's really nothing complicated at all, but the take-home message from this exercise is that you could use all of these things on your own objects as well. as long as you implement, you know, the right functionality. Okay, so here is what the main class. So sort the fraction. What I'm doing is I'm taking, you know, the size of the list. So how many fractions do I want to put in a list? Okay, then I'm generating these guys, these fractions randomly. Okay, so I'm gonna just here print where L is a list of fractions for now, and then I'll comment this out. Okay, just to see that what is happening in the program. So the program, all it does is it, you know, imports the class fraction that I've implemented before in previous assignment. If you want to look at it, it's this, yeah, which has, you know, all sorts of things like it's basically a numerator and a denominator. Then I have all these methods like add, subtract, convert, and so on. Yeah. Okay. Simplify, greater than, and less than. Okay, great. Now, once I have this, I just here importing it, so importing this class, so I can use it as if it's any other class in Python, and I'm just generating a list of random fractions. So let's see it. So I'm going to do the following: Python sort fraction py, and I'm going to say give it 100. So I want 100 fractions to be generated. What I'm doing in the code is I'm doing the following, right? I'm generating the numerator randomly as a value between 1 and n, yeah, so 1 and 100, and the denominator as a value random as well between 1 and 100, and then creating a fraction based on these random values. Now here, the problem is when I said print the list, it print a list of addressees of objects, yeah? So I have to really loop over every element inside this list or every fraction and use the print it individually because I want to print the values. Yeah? So I have to do this. Otherwise, it's going to just print that addressee because the list contains, you know, objects of type fraction, so it's not going to be able to use the string method. So I'm going to loop here, you know, for E and L, print, and it's going to print these guys now in a more friendly way. And here it does, it prints every fraction, you know, in a line. So the first fraction was 74 over 69, the second was 73 over 85, and so on. It's obviously not sorted. Yeah, what is the problem with this? Yes, Rawad, then? Just an easier way for me to generate these fractions. I don't want them to, you know, I don't want to insert 100 values. Yeah, I specified the number of elements, right? So I inserted the number of elements, right? I want 100 fractions. And now how I'm generating these fractions, I'm saying, okay, the numerator for every fraction is going to be a value between 0 and 100, or yeah, or 1 and 100 particularly, yeah. And the denominator is also going to be a value between 1 and 100, yeah? Just to generate these fractions, because I don't want to insert, you know, 100 values myself. Yeah, this is orthogonal completely to the exercise. I have a list of fractions. That's all I have, a list of fractions, and I want to sort them. It's obviously these guys are not sorted. I won't sort them based on their values. Okay. So I'm going to use my merge sort, the algorithm we've discussed the last time, and here's how I'm doing it. Okay, so I'm going to remove this. Okay, so the merge sort. Here's the two functions that we have from before, right? So this is the merge sort algorithm. It's a recursive algorithm, you know, split in the middle and sort the first half and the second half and then merge. Okay. Now, the only difference in the exercise, we wanted this to be done both ascendingly and descendingly. So I'm able to tell whether I want to sort them from small values to large values or vice versa. Okay. So I added this parameter ascending, which is by default true. So if it's not specified, I sort them ascending. If it's specified, you know, I have to sort them based on the larger value first. The only thing that changes is the merge function. Yeah. So if ascending, if really, you know, I'm doing merge ascendingly in ascending order, then it's exactly as we've written it in the slides the last time and the code that I've shared with you on Moodle. If it's descending, then I want to make sure that I check, you know, the largest element from the list one with the largest element from the list two, the two lists that I'm merging, and put the larger one first. Yeah, append it in the new list first. So this is exactly what I'm doing. If it's ascending, then compare, you know, the smallest element with the smallest element, and in the merged or in the new list that is the merge of these two sublists, put the smaller element first. Otherwise, I check whether, you know, this is greater than that, and then put the greater value first. Okay, that's really how it works. Remember that I start merging with just lists of single elements. So this will build up. If I decide to do it descendingly, I'm going to put the larger element first, and then the smaller one, and that will, you know, continue throughout the whole thing and the whole sort. Okay, so just a subtle detail here. Okay, so now I have this merge, you know, sort algorithm. I want to use it to sort my fractions. Okay, so all I did is just say, okay, call the merge sort, give it the list L, and we'll start with ascending equal to false. Yes, you can take it as a command line. Okay, so now I want to sort based on the merge sort. I'll show you first running it. So I called merge sort, the one that I've just showed you, the function that I just showed you, and I said, right, ascending is false. This meaning that I want it to be in descending order. Okay, now this will sort the list. So sorted would be, you know, a sorted list of these fractions. I'm going to print them. So let's see it, and then I'll explain something very important. Okay, I'm going to do clear. Y, again 100. And as you see, it's now printing them in descending order. So 54 over 4, and then 66 over 7, then 26 over 3. You know, obviously these numbers are greater than 1. And as I go down, I start getting to the smaller values. So you're right, if you see 76, now I'm starting to get less than 1, and so on. Okay, until I reach really small values like 1 over 74. That's the smallest value I have in the list. Okay, you can also say ascending equal to true, and now it's going to sort them from smaller to larger. So you see now the values greater than 1 are here, 81, and then you have 96 over 3, and so on. The smaller values are on top. Okay. Now I have a question for you. Can I do this for any object? So let's say I have created an object called, I don't know, students. Yeah. Can I take now, create a list of students and just say sort them? What do I need to define in the class to be able to use this sorting, you know, functionality? There is something that I need to implement. What is it? The less than and the greater than. Exactly, right? So why the less than and the greater than? Is because here, I'm using them here. So if I don't implement these functions, if I don't have a specific way of deciding whether two students are less than each other or greater than each other, as Nasreen said, then this function or this method is not going to work, right? This approach of using the merge sort, because it implicitly, the code uses this less than operation and greater than operation. Now, L1 of I is a fraction, and L2 of J is a fraction, and so I have to define this less than or greater than, you know, method. Otherwise, the code will not understand. It will say, you know, these things are not implemented. So if I remove this from the fraction, let's see. We run. gonna give me an error. Yeah, immediately that's right. There is function not here, right? The less than not supported between instances of fraction and fraction. Okay, so I really have to, if I'm doing something, let's say I'm doing something where I'm checking inside of some function or code, an object is equal to another object, then I have to implement this equal function in my code. Right? That's it. I'm done. So tell me, any questions that you have, any concerns, anything you want to say? Okay. Similar, very similar to the previous exam chat. Yeah. So most likely it's going to be an hour and a half, 3 questions, each 30 minutes. And just similar, very similar to the last exam. Okay, just make sure that you understand, that you like review complexity, review sorting, and so on. The material at the end will definitely be part of the exam. Other questions? Okay, guys. Yeah, I want to say that I hope you've learned, a few useful things. I think it was a tough semester for everyone, especially that we haven't met at all. So the last semester was, at least I've got to see the students to half of the time, but the semester was totally virtual. So I hope this wasn't very difficult for you. I know also the internet connections was an issue, but I think overall you've been doing really well. So hope to see you in person next semester, or maybe very soon. Okay, good luck. I'll be available. You can send me emails if you have things you want to discuss later on before the final exam. Okay, everyone. Well, good luck in the final, of course, for all the exam. Yes, hope so. To help. Okay, so I'll see you in the finals. Good luck.
Goodbye, Professor.
Bye bye. How do I